So, in the last lecture, what we were doing, we have done the laws of accuracy, right? We were doing laws of accuracy, and for that, we have started an example that is the quadratic equation 1.002x square plus 11.01x plus 0.01265 is equal to 0. And then we have used 4-digit rounding in this. 4-digit rounding that we have rounded at every step. Then we have evaluated one of its root x1 that was coming out to be your minus 0.004990. And if you calculate your x2 will be your minus 11.01 minus 11.00 divided by 2.004. When you will do the subtraction, this is coming out to be 22.01 divided by 2.004, and then this will be your minus 10.9830. When we will round off this number to 4 digit rounding, then this will become minus 10.98. So this is the 4-digit rounding, right? So we got these two roots as the approximate roots, and we have obtained that x1 and x2 were your using MATLAB, that was minus 0.0011490756 up to so on, and your second root was minus 10.986874876435, right? This was your actual root that we have calculated. Now we will see, since we have used 4-digit rounding, what happened with the roots. So if you see here that you find the relative error in x1, that is x1 minus x1 star divided by your x1. So this will coming out to be your 3.34. And if you talk about the percentage error, so when you will multiply it with 100, that is 334% error. That means this error is very high. So we can't tolerate this error. And we can also check the second root x2 minus x2 star by x2. So when you calculate error, the percentage error, this is coming out to be your 0.06%. This we can say this is very reasonable. So having 0.06% error is okay than having that is 334% error. So why it happens? Because if you see, we have done the loss of accuracy. In the loss of accuracy, what we have done, you can see from here that this, when we were doing minus 11.01, in this case we were doing minus 11.01 plus 11.00 divided by your 2.004. So you can see from here, this is the subtraction of two nearly equal numbers. So that's why the error has occurred, and we have lost significant digit in the first step. Then we have divided. So what we can do to overcome this situation, so that we can maintain our accuracy, to overcome this situation, we can avoid the subtraction of two nearly equal numbers. That means we can reformulate that step. What was the step? That the step was, I have considered the root x1 star, I have evaluated, that is minus b, right? It was plus root of b square minus 4ac, and we have used 4-digit rounding here. Now we have seen in this case, we have subtraction of two nearly equal numbers. So what we can do in this case, we can reformulate this function so that we can avoid the subtraction of two nearly equal numbers. So when you will solve this, you will get that will be your minus 2c, because this is a minus b into a plus b. So this will be b square minus 4ac upon the same term 2a into minus b minus root of b square minus 4ac, right? So this we will get, and when you will solve this, you will get minus 2c b plus b square minus 4ac. So now if you calculate, if you use the 4-digit rounding in this case, you will get x1 star, that will be your minus 2 into c, that is minus 2 into, and c was your that was 0.01265, right? Divided it by b plus b square minus 4 into AC, and A was your 1.002 and C was your 0.01265. So if you remember, we have calculated this using 4-digit rounding, and when you will solve this, you will get this is minus 0.001149. So now we can check the relative error in this case. So that will be x1 minus x1 star divided by x1. So if you will calculate, this will coming out to be your, if we calculate the percentage error, this is coming out to be your 0.0065%. This is very small as compared to the previous one. There you got the error as 334%, which is very high. So just you can see, we have just reformulating the functions and we got the accurate answer, right? So you can reformulate. So to avoid the subtraction of two nearly equal numbers, आप significant digits आपकी lose ना हो, so that you can reformulate the function. So you can notice one remark over here. Since you know that the product of the roots is equal to c by a when you do x square plus minus sx plus p. So product of roots is c by a. So because your x2 root, जो आपकी x2 root निकली है, उसमें error आपका बहुत कम है, then you can also that use that error. So that is x1 star is equal to x2 star. That will be your c by a, and then you can calculate x1 star by c by a into your x2 star, right? So if you will evaluate this, even then in that case you will get the same. This will be your minus 2c b plus b square minus 4ac, that we have already calculated. So you can also use this. क्योंकि आपका जो x2 है, x2 में आपका एरर ऑलरेडी बहुत स्मॉल है, अगर आप उसको रीफॉर्मुलेट करोगे, दैट यू अगेन रैशनलाइज दैट स्टेप, तो इट मे बी पॉसिबल उसमें एरर ज्यादा आ जाए, क्योंकि इट विल कंटेन द सब्ट्रैक्शन ऑफ टू नियरली इक्वल नंबर्स, राइट? So this you can do, that you can reformulate the function and to save your accuracy. One more thing that we will do, the nesting arithmetic. So you can also maintain your accuracy by just rearranging the terms which it has contained. So it means accuracy loss due to round off error, due to round off error can also be reduced by just rearranging the calculations, by just rearranging the calculations. So we will continue with this example. The example is like, if you have given that you have to use 3-digit rounding, you have to use 3-digit rounding to evaluate f of x is equal to x cube minus 6.1 x square plus 3.2x plus 1.2 at x is equal to 4.71, right? So now the question is कि हमें 3 digit rounding use करनी है, and this was the function that we have to evaluate, and this at this point we have to evaluate this x. So I am writing here, but we need to calculate. One is x is given to you. Next you have to also calculate x square. You have to calculate x cube. You have to calculate 6.1 into x square. You also have to calculate 3.2x, right? So we are writing, so exact, I am writing the exact, and here I am writing the approximate so that we can use it. So now you can consider in the exact 4.71, this has already 3 digits. इसमें आपकी 3 digits ही हैं, significant हैं जो, ठीक है? So that means we need not to round off. अब आपका next step क्या है कि आपको evaluate करना है x square. How you calculate your x square? X square आप कैसे calculate करोगे? That is the multiplication of x into x. So that is coming out to be your 22.1841, and x cube is your x square into x. So that will coming out to be your 104.48711, and 6.1 x square, that means you will multiply x square with 6.1. So this will coming out to be your 135.32301, and 3.2x, this is coming out to be your 15.072. Now the approximate one. Approximate में हमें 3 digit rounding use करनी है. पहला तो step जो है वो same ही रहेगा, that will be 4.71 because it has 3 digits. Now x square के लिए हमें क्या करना है? 3 digit rounding करनी है. 3 digit rounding करोगे तो आपका क्या होगा? At the fourth place you have 8. अगर आप rounding करोगे तो इसका आंसर क्या आ जाएगा? 22.2. Now x cube, right? x cube जब आपको इवेल्युएट करना है, आप इसी को राउंड ऑफ नहीं करोगे. व्हाई? बिकॉज x क्यूब इज कैलकुलेटेड जब आप क्या करोगे कि आपने x स्क्वायर को x से मल्टीप्लाई किया. राउंडिंग आपको हर स्टेप पे यूज करनी है. अब आपका x स्क्वायर जो इवेल्युएटेड आया, दैट मींस व्हिच हैज 3 डिजिट राउंडिंग, सो दैट इज योर 22.2, and in x it is your 4.71. When you will multiply this term, you will get 104.562, and then when you will use 4 digit rounding in this, 3 digit rounding in this you will get 105. So आपको याद रखना है कि आपको जो राउंडिंग आपने यूज करनी है वो हर स्टेप पे यूज करनी है. अगर आप इसी को राउंड ऑफ कर देते, दैट आई हैव कंसीडर्ड दिस, तो आप 104 लेते, 105 नहीं, राइट? So that will be wrong, because rounding you have to calculate your every step. Again in this step, x square that you have calculated, that means this is your 22.2. This will be multiplied 6.1, and when you will round off this thing, this is coming out to be your 135 point something. So that digit is less than this thing, so this is 135. And when you evaluate this thing, 3.2 into x, so this is coming out to be your 15.1. So now you can calculate your f for the exact value, and you can see the difference. So f at exact answer, so that is my 104.487111 minus 135 point. So this is 111, right? And this is 135.32301 plus 15.072 plus 1.5. So if you see and you do the calculation, this is coming out to be your minus 14.263899. And on the same hand, if you evaluate your f at the approximated value, this is coming out to be your 105, right? Minus 135 plus 15.1 plus 1.5. So if you will calculate, this is coming out to be your minus 13.4. And if you calculate the error in this term, your relative error, that means a relative error means आपकी exact value minus the approximated one, divided it by the exact value. So that will be your minus 14.263899. That will be minus of 13.4. That will be plus 13.4. Take the modulus, divide by your exact value minus 14.263899. And this is coming out to be your 0.06. And if you calculate the percentage error, this is 6%. Even 6% error is also high. So that means that you cannot tolerate. If this was percentage error in this, then that is reasonable. But this is very high in case of accuracy, right? So what we can do, why this happened? Because we have done the rounding at every step. अगर आप उसको आप रीअरेंज कर दो कैलकुलेशन, जैसे हमने इवैल्यूएट किया, f of x was my x cube minus 6.1x square plus 3.2x plus 1.5. If you can rearrange like this, that is your x into x minus 6.1 into x plus 3.2 plus 1.5. And now when you will substitute, x is your, like you are calculating at x is equal to your 4.71. So when you will substitute, this is your 4.71. This, the inner bracket will be 4.71 minus 6.1 into your 4.71 plus 3.2 plus 1.5. So when you will solve this, firstly you will solve the inner bracket, that will coming out to be your minus 1.39. Then this will be multiplied by 4.71 plus 3.2 plus 1.5. So this is your, when you will calculate 4.71, when you will do this and you do your rounding, so this is coming out to be your 6.55 plus 3.2. You have to do rounding at each and every step. So this is coming out to be your, when you will do it, this is 4.71. This is coming out to be your minus 3.35 plus 1.5. अगर आप इसको सॉल्व करोगे तो आपका आंसर आ रहा है माइनस 15.8 plus 1.5, and now you got the answer as minus 14.3. Now if you calculate in this case your relative error in this case is coming out to be your minus 0.0025, and you talk about the percentage, so this is 0.25 percentage, which is very less as compared to the 6% error. So just you have सी कि हमने सिर्फ टर्म्स को रीअरेंज ही किया है, एंड वी गॉट द एरर एज 0.25% इंस्टेड ऑफ योर 6%. So that means you can see over here, when you have calculated this x square x cube, यहाँ पे आपने x square के लिए multiplication यूज की, 2 times you have used multiplication, and here you have used again x square into x, that you have again used 2 times multiplication, x square into 1 time multiplication. In this case you have also calculated 1 time multiplication, so total 1 plus 1 2 4 6 times you have used the multiplication. And now you can notice over here, we have just the addition and subtraction, and we have just multiplied. This was the term 1 time, I have multiplied, and this is the term that I have. So I have used 2 times multiplication, and in the previous one I have used 6 times multiplication. So the error was more in the previous case, right? So you can rearrange the terms to calculate your, to save your accuracy, to calculate, to do your calculations. So next the questions, or can be, you can say, how many multiplication and additions, how many multiplications and additions are required to determine a sum of the form summation I is equal to 1 to n. summation j is equal to 1 to I, ai, bj, and next modify the sum to its equivalent form to reduce the number of calculations. To reduce the number of calculations, right? Now you can notice here we have to evaluate this term, that is the sum of this thing. So we will solve this. Now we have to evaluate I is equal to 1 to n, and your j is varies from 1 to I, a, I, b, j. Now if you fix n is equal to 1, you will have only one term, because j will varies from 1 to 1, because I is varying from 1 to n, that will you have only a1 as b1. When you fix n is equal to 2, so I will varies from 1 to 2 and j will also varies from 1 to I. So that means a1 plus b1, plus you will have terms a2 into b1 plus a2 into b2. If you fix n is equal to 3, you have this terms plus this term a3b1 plus a3b2 plus a3b3, and up to so on. If you continue it for the n times, you will have a and b1 plus a and b2, up to so on. You will have a and bn. Now we will count the number of addition and the multiplication in this case. So you can notice here. So we are counting firstly the multiplications. So you can notice in the first step, the multiplication is for the one time, because a1 is multiplied with the b1. In the second, a2 is multiplied with b1 and a2 is multiplied with b2. So you have multiplication two times. And here, one time, two times, three times. So this is your three time. In this continue, you will have n times. So if you total, do the addition. So you will have n into n plus 1 by 2 multiplications. And if you count the addition, if you count now addition, I am ignoring this first. Okay, we are not counting this in addition, we are counting. So in this, we have no addition. So this is zero addition. In this, we have one addition. In this, we have two addition. And in this case, we will have 0, 1, and this is your terms. And in this case, we have n minus 1 addition. So you will have this case. So you will have 1. So this is your 2. This is your n minus 1. When you will add up, this is 0, 1, 2, 1 plus 2. Up to n minus 1. If you count, this is your GP. So this will be your n into n minus 1 by 2. Now I am counting the last addition. So the last addition, this is your addition here one time. This is your addition here one time addition, and it is in the last there is no addition. So that means this addition is going up to your 1, and this is your n minus 1 time. So your addition is n minus 1. So you can notice, so in this case, you have total operations, that is your multiplication n into n plus 1 by 2 plus addition when we have ignored the last one, and this is the last addition. So when you will calculate, that means you have total n square plus n minus 1 total multiplication. So when you can modify it, we have just seen that we have done the nesting. So if we modify this is I is equal to 1 to n ai, and then we have j is equal to 1 to I bj. If you calculate like this way, you will get a1 b1. The first term will be same, but in the next, this will be a2 into b1 plus b2, right? This term will become a3 into b1 plus b2 plus b3 up to so on, right? And the last term will be a and b1 plus b2 up to bn. So now you can see the number of additions will be same in this case, but you have reduced the number of multiplication. So in this case, you have multiplication. So here you have multiplication is that the multiplication is one time. Again, when you will do, this is one time, this is one time, this is n times. That means in this case, we have total multiplications is one time here, one time here, and up to last time one time here. So that means the multiplication has reduced to n, which was earlier as n into n plus 1 by 2. So in this, additions will be same. So in this case, you will have total computations that you require, that will be your n square plus 3n minus 2 by 2. That means this is the total computation that you require. Earlier it was n square plus n minus 1. So you can reduce your calculations by just rearranging the terms. Okay, thank you.